right, 8b.3 is very similar to 8b.2. I can calculate the measure of an inscribed angle or an arc by understanding the relationship between that should say inscribed. Let's fix that. Between an inscribed angle. Okay. So again, this is very similar to what we just did, but we're looking at inscribed angles, again, which are made up of chords, instead of central angles, which are made up of radii. Okay. So, inscribed angles and their arc measure. So it's a slightly different relationship. Before we had the central angle equals the arc measure. Here, 2 times the inscribed angle equals the arc. Okay? So that's a little bit different. And these will not be given to us on the test. These we do have to know. So, again, we might have to use some other things. We still might have to use that circle is 360, and a semicircle is 180, vertical angles are congruent. The other thing, remember that triangles also add up to 180 degrees. That might also be something, especially with inscribed angles, that we have to use. All right, so let's look at example 1. Find the missing angle or arc. So, right, we have what we're looking for here. There's x. Okay. So now our relationship is 2 times the angle. I'm going to say 2 times inscribed. Is equal to the arc. Okay? So 2 times my inscribed angle is here, right, where x is, equals my arc, which is 80 degrees. Now I'm just solving this. X is being multiplied by something, I'm just dividing. Okay? So it's simply just one more step than what we were doing with our basic central angles. Okay? Let's look at example 2. Same thing, same relationship, 2 times inscribed equals the arc. Right, I'm solving for this here. So I have my inscribed angle and my arc here. The fact that there's a line doesn't affect our problem in any way. But this is part of a triangle, doesn't change that 2 times this is going to give me that. Okay, so 2 times my angle is 42 degrees, my arc is x. These are on the same side, so I'm just doing what it tells me. 2 times 42 is 84 degrees. All right, let's look at example 3. Okay. So I want to look at what I have and what I'm solving for. Okay. I have this angle, and I'm solving for this angle. Okay. Well, this angle can give me this arc, so I'm going to call that y and solve for that first. So again, 2 times your inscribed equals your arc. So 2 times your inscribed angle is 25 degrees. Is going to equal your arc, which is y. So that's 50 degrees is going to be y. Now when I want to solve for x, well, these lines, right, this angle intercepts that arc. So I have, again, 2 times inscribed equals the arc. Well, now my inscribed is x. equals my arc, which is 50. If I divide that by 2, then x equals 25. Fine. And this is actually a theorem that we call the inscribed angle theorem, what we just found. And the inscribed angle theorem states that if two inscribed angles intersect the same arc, then the angles are congruent. Okay. Or, right, congruent just means equal. So since these two angles both, right, end on the H and I, that means those two angles are the same. Okay, so that's a good rule to know. You can also, if you can't remember that, you can also just solve exactly like we did, right? These theorems are just kind of ways to speed it up. All right, looking at example 4. I am solving for this arc here. Okay. It goes from D to C. So if I look at that angle, right, I probably need that angle there. So, can I solve for this angle? The answer is yes. That angle Y is part of this triangle. And remember, all the angles in a triangle add up to 180 degrees. So I have Y plus 49 degrees plus 70 degrees is going to equal 180 degrees. These are on the same side, so I'm just adding them. So Y plus 119 equals 180 degrees. Then I'm just going to subtract 119 from both sides, and Y equals 61 degrees. Now that I have that angle, it's easy to solve for the arc. Now I'm just doing 2 times inscribed equals the arc. So my inscribed is 61. My arc is x. So 122 degrees equals x. And we are all done. Go ahead, work on B3.